Greetings everyone. Welcome to an episode in Career in Space Science. Through this presentation, we will understand what is space science and then how you can pursue a career in this. Firstly, let us understand what exactly is aeronautical engineering. Aeronautical engineering and astronomical science graduates, or as some would prefer to call it, training to be a rocket scientists, are technologically one of the most advanced branches of engineering today and can be a preliminary step towards a career in space science. This branch of engineering involves examining, analyzing, designing, and manufacturing, occasionally installing components that make up civilian and defense aircrafts, spacecraft, high-altitude vehicles, and high-altitude delivery systems, missiles. The focus is mainly on design and development and involves space and satellite research. Aeronautical engineering graduates work in all areas of the aircraft and airline industries. They also work in other high technological industries such as motor manufacturing and offshore oil and gas extraction. These engineers design, develop, and produce new commercial or military aircraft, develop more powerful but also more eco-friendly jet engines, manage the tight schedules of aircraft service and turnaround for a major airline. You will deal with theoretical and computational aerodynamics, applying methods to actual wing design, thermodynamics, one-dimensional gas dynamics, and one-dimensional wave motion, waves in supersonic flow, flow in ducts and wind tunnels, method of measurement, the equation of frictionless flow, subsonic and supersonic flow around a wing, etc. What should you study if you want to pursue this field? You should have passed 10+2 with physics, chemistry and mathematics, and for those interested in doing an MTech and a PhD in aeronautics, there is a course offered by Indian Institute of Science, Bangalore. The Aeronautical Society of India (ASI) conducts an associated membership exam, and those students who clear this exam can also become aeronautical engineers. The study focuses on the fundamentals of propulsion, fluid dynamics, structural analysis, material science, guidance and control systems, thermodynamics, aerodynamics, acoustics and electronics. The prospects in this are, especially in India, there exists a lot of opportunities for aeronautical engineers in government agencies such as Hindustan Aeronautical Limited, Indian Space Research Organisation, Airports Authority of India, Aeronautical Development Agency, National Aeronautical Laboratory, National Aeronautical Laboratory, Hindustan Aeronautics Limited, etc. as a research engineer or a maintenance engineer. The airline force and the airlines such as Air India, Indian Airlines and other private airlines also employ aeronautical engineers for the maintenance of their aircraft. The most aeronautical engineers that take work are in research and development areas in the Ministry of Defence and Civil Aviation. The top campuses for aeronautical engineering are Martiniere College of Aeronautical and Applied Sciences, School of Aviation Science and Technology, Indian Institute of Aeronautics, Indian Institute of Aviation Technology Haryana, VSM Aerospace, Hindustan Electronics, Indian Institute of Aeronautical Engineering, and the postgraduate courses in aeronautical engineering are MTech and PhD programs. The Madras Institute of Technology offers a 3-year graduate program in aeronautical engineering for BSc students subject to their having passed maths and physics at the graduation stage. The Indian Institute of Science IIS Bangalore has MTech and PhD programs in aeronautics as well. And with that, we hope you have understood this vast field in a much better manner and hope that you are interested and eager to learn more from the career expert in the next section of this particular podcast. Thank you so much. Greetings everyone. Welcome to the Season 3 of Martiniere Career Fair. With us today, we have an eminent personality in the field of space science, Dr. Anil Bhardwaj. Sir is a distinguished scientist with a remarkable career in planetary and space sciences. He earned his Masters of Science degree from the Lucknow University in 1987 and completed his PhD at the Indian Institute of Technology, Banaras Hindu University in 1992. His career at the Indian Space Research Organisation ISRO began in 1993, where he initially worked at the Space Physics Laboratory of the Vikram Sarabhai Space Centre. Dr. Bhardwaj's pivotal role as the principal investigator for the SARA experiment on the India's first lunar mission Chandrayaan-1 has revolutionized our understanding of the interaction between solar wind and the moon, and he has also led various experiments on missions like Chandrayaan-2, Chandrayaan-3 and the Aditya L1 solar mission. With a wealth of over 170 peer-reviewed publications and numerous awards, including the prestigious Shanti Swarup Bhatnagar Prize and the Infosys Prize, Dr. Bhardwaj has significantly advanced our knowledge of the solar system and space sciences. His impressive contributions to the field continue to shape planetary and space science research. It is our privilege to have you here with us today, sir. Thank you so much.
Greetings, everyone. Welcome to the Season 3 of Martiniere Career Fair. Today with us, we have an eminent personality in the field of space science, Dr. Anil Bhardwaj. Throughout the course of this episode, I am certain that every viewer who is watching this particular episode will gain a lot of valuable insights into the field and the career of space science. So, sir, thank you so much for being with us. And the first question that I'd like to ask you is that what sparked your interest in space science and what led you to pursue a career in it? Could you please share with us?
Thank you, Roman, and thank you, Keshav, for interviewing me. You may not be probably aware about, but I basically belong to Lucknow. So if you look at my initial days, I was a kid interested in looking at the sky, and of course doing all my studies of schools and colleges and university. I did my BSc with a combination of physics, mathematics and statistics, and did my master's in physics. So I'm basically a physicist by training. But when you talk about space science in general, it encompasses various branches of sciences. It includes all the branches of engineering and technology and all possible science domains you can think of. For example, physics, chemistry, mathematics, even now biology when we are talking about the Gaganyaan program in India, and all the engineering and technology branches like electronics, communication, computer science, material science, civil, mechanical, electrical, propellant, and any domain which you can think of. So what is essentially required for space science or space program of the country is you should be best in your own domain of work. And secondly, you should have a passion to work in the space science. So these are the two primary requirements.
Thank you so much, sir, for that answer. It is all the more our privilege to learn about the fact that you yourself are from Lucknow and have your background and personal life situated in Lucknow. Sir, in your answer, you talked about what space science actually is and how broad it is. It contains physics, it contains astronomy. This also brings me to my next question which I have for you, which is, in the presence of all these different variables, how does one actually define space science and its role in expanding our knowledge of the entire universe?
Okay, so space science means anything about the surface of Earth, we can call it as space, right? And as you go up, we call it as troposphere, stratosphere, mesosphere, thermosphere, ionosphere, magnetosphere, sun-planet connection, interplanetary medium. And then you go outside of our own solar system, you talk about the stars and galaxies and things like that. And then the whole universe. So space science encompasses various branches of science which deals with anything about the surface of Earth. Okay. Some people call near Earth space as atmospheric science, right? Some people say that I work in meteorology. So they look at weather and climate and things like that and how does affect us. But all these different domains of sciences combined together comes under the broad theme of space sciences, which includes all those branches which you have just mentioned to me, like astronomy, astrophysics, astrochemistry, astrobiology, right? So the focus is now moving towards interdisciplinary branches. Astronomy and chemistry, astrochemistry. Astronomy and biology, astrobiology. Biophysics, so biology and physics. Biochemistry, biology and chemistry. So because what happens is, if you are confined into a classical domain of chemistry, biology, physics, mathematics and things like that, you find that you are not able to progress because there are a lot of interdisciplinary areas or interplay between different branches of sciences which has to be understood well. And that's why, even the courses in various universities and colleges currently are in this kind of domains. And that is why all this, whatever we can think of with respect to anything happening above the surface of Earth, comes under the category of space sciences. Now you may say that how do we do actually space sciences, right? What are the ways? One way is to look at the objects, either remote sensingly or in situ. And second way is to do theoretical simulations or modeling, right? So these are the two different ways in which you actually explore the space. In the case of Earth, when you are going a few tens to hundreds to thousands of kilometers, we have rockets which can take us to there and you can make measurements. For example, you must have heard about India landing on the moon, right? On 23rd of August in the evening at 6:04 p.m. And that made India the only country in the world to be landing around the southern pole of the moon. But how it was possible? It was possible because there was a rocket which was developed within the country, a satellite, that is the Vikram lander and the Pragyan rover, going on that rocket. It goes into a region which we call as a geo-transfer orbit, from where the spacecraft itself goes towards the moon, and then it goes in an orbit around the moon and then lands onto the lunar surface. So all this process, if you look, it requires people in various domains of science and technology. It is not just one domain of, for example, aerospace engineering. No, it's not that. We need experts in material science. We need experts in thermal mechanism. We need experts in mechanism, materials, electronics, computers, right? And then those people who do this orbital dynamics calculations to say at what speed, at what velocity, at what angle I should move into the space, right? So this all branches of different domains of science and technologies are required to do that. And the other way which we do science is, I was telling you about simulation and modeling, but also remote sensing. For example, if I look at a star or a galaxy around from an orbit around the Earth or on sitting on the Earth, then I can do it at different wavelengths. For example, if I use radio waves, I can have a big antenna, like we have a giant meter wave radio telescope in Pune, and which is huge antennas of big sizes of about 35 meters single, and there are 30 of them put together. So we use that to look in the radio waves, to look at the various objects in the sky. So I am doing remote sensing now. I am sitting here and looking at those objects in the radio domain. But if I had to use X-rays or ultraviolet, which is absorbed by the atmosphere, then I have to go above the Earth's atmosphere or higher up, so that those radiations are not absorbed by the Earth's atmosphere. So it depends upon the science needs of how we can do science, and there are ways in which we do science in different domains. So there are ample opportunities for young students like you to come into the domain of space sciences. Choose your own ways in which you want to contribute into space sciences.
Thank you so much, sir, for that comprehensive and detailed answer. That indeed is very motivating to know how far India has come in terms of space science with all the new advancements that are coming, especially with technology. And that leads me to my next question that I have for you, and that is the period of time that mankind has existed. Could you tell us more about what have been notable achievements that we have done?
Space science, I was just mentioning, there are different ways in which you do exploration. One is you go to the object, like we have gone to the moon, we have mission to Mars, right? Earlier also we had a mission to moon, and we are now talking about going to Venus or to an asteroid or a comet and things like that. And the second way of doing it is sitting on the planet Earth itself. I can do and study, right? So it depends upon what is your objective and whether you can do it in situ or remotely, right? Now, if you look at India, over the last several decades, there have been a significant advances which has happened within the country. Earlier, we were depending upon countries like US or Europe or Russia to do our own satellite launches. But now the country has its own big rockets by which we can do any exploration within the solar system currently. And we have our own satellites. The way now I'm talking to you, it is all possible because we have satellites in space which are helping us to do this communication, right? So the advances in science and technology have led to shorten the time period which we had or which we used to have in the past. And this is applicable in all domains of our social life. Whether it is communication, whether it is economy, whether it is going to ATM and drawing money, right? Or talking about going from one place to another place with the advances in flights, or even higher fast trains, or higher capability of driving through the cars. So the advances in science and technology has taken a big step in the last several decades, and that has eased our life, which has improved our communication skills. We are able to talk to each other sitting from any place around the world instantaneously, right? And this is all possible because of advances which has happened within the country, and not only within the country, of course, all over the world. So if I can say in a small or nutshell that it is basically science and technology which is driving the development and progress of any country.
Thank you so much, sir, for that comprehensive answer. It is all the more a privilege to hear about what scientific advancements we as a nation have made in the past. Whether it be, having satellites to connect even you to this video call, or to launch our own rockets into the space. So this also brings me to my next question which I have for you today, which is, what were some of those primary projects and initiatives that you as a space scientist have undertaken during the course of your career? If you could please help us understand them and some of the key findings or breakthroughs which you've discovered while working on them.
So as I was telling in the beginning that I had my graduation and post-graduation from Lucknow University in physics, and I had a specialization in electronics and X-rays. But then when I started thinking about having a PhD, which I did from Indian Institute of Technology in BHU, Banaras University, I moved on to space sciences and in particular planetary sciences. And I started working into looking at the processes which is happening in the upper atmospheres of various planets in our solar system, including comets. And comets, which are very small bodies of our solar system, which are largely made up of water vapor, H2O. Okay? But they are chunks of rocks combined together, and as they come close to the sun, they give out a lot of sublimation of this water, because it's a movement or basically from solid phase, it goes directly to gas phase. So there is no liquid phase in between. So it's called sublimation, right? You must be knowing in your school days. Now, those kind of studies led me to think that I should also start looking at these objects at different wavelengths. And then I started not only doing theoretical modeling and simulations, I started looking at observations being carried out by Hubble Space Telescope, by Chandra X-ray Telescope, XMM Newton, which is basically looking at X-ray and ultraviolet and things like that. And then, as India started progressing into space science and technology, and there was discussion happening within the country, and in particular within ISRO, that can we have a mission to the moon? And I'm talking about 98-2000 time frame, about 25 years back. Okay, and that was a time then I was involved into doing a planning to have a Indian lunar mission, because by that time we had the capability of our launch vehicle and the satellites to go into space and at least go to the moon. I got directly involved into that mission. That's the Chandrayaan-1 mission, where I had an instrument which was flown on the Chandrayaan-1 mission. Around that time frame of 2007-8, because the launch was on 22nd of October 2008, we started thinking about going to Mars. And we had the launch of the Mars mission, which is called Mars Orbiter mission, in 2013 November. And after 10 months of travel, we reached Mars. And that made India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. And subsequent to that, there was of course discussion about Chandrayaan-2. I was involved in Chandrayaan-2 mission. We had an instrument flown on Chandrayaan-2. We had an instrument flown on the Mars mission, and then the Chandrayaan-3. So I have been involved into a journey of developing instruments, flying on various missions, and bringing out science. And it gives a joy, it gives a satisfaction to me that I am contributing in a big way into the science and technology within the country, and also bringing out something new for the whole world. So it's a kind of satisfaction which comes when you work in this domain of science and technology, but more particularly in the area of exploration of planetary systems.
So I'd also like to know, how do scientists approach the search for habitable environments and potential signs of extraterrestrial life? Since you mentioned that Chandrayaan-1 mission in 2008, then we wanted to explore, as a nation, we wanted to explore Mars at that point of time. So what are the signs that space scientists look for, especially when looking for habitable environment and extraterrestrial life?
Okay, this is a million-dollar question of searching life in not only within our solar system but also beyond. And you must have heard about exoplanets or extra solar system planet, that is planets beyond our solar system. The way to look for life within our solar system itself is to search clues of life, but generally what happens in the case of science is that we get biased by the way we look at ourselves or the life around us, and we say that a life is something which requires probably oxygen in the initial stages when we are all working about few decades back. And then we said no, oxygen is not an essential aspect, because oxygen can come out by breaking any of the oxygen bearing molecule. And therefore we said O is not, or O2 is not important. It could be CO2, it could be H2CO, it could be CH3OH. So anywhere which is O is involved, that could have life. Okay. Now, as we know, in our solar system currently, there is a possibility that life may have existed on Mars or would be existing on Mars, because there are clear signatures of presence of water on Mars. And Mars has an atmosphere dominated by carbon dioxide, that is CO2. And if you break CO2, you can get O2, which is required by a living being like on Earth. But we also know in the case of Earth that life does not only use O2 or oxygen. There are life which just sustains on many other possible source of energy. So what is required now is a source of energy. And there are single cells which is present on the planet Earth itself, which are deep down in the oceans or are in very harsh environment, and they are able to sustain themselves. So then the question comes, so what happened to planet Earth that it is having a life which is in full grown form, as we call as humans? And we are not seeing such signatures on any other planet. But if you look at the planet Earth itself, you see the form of life which you are talking about is hardly few thousands of years old. Whereas the Earth itself is 4.5 billion years old. So that means this is a long-term process which may be happening on the planets in our solar system itself, and probably 10,000 or 100,000 or several million years later, life may exist on other planets in our solar system, or would have existed on other planets in our solar system. And therefore the question comes is that how do we identify them? And currently we are looking at life either on the surface or beneath the surface. When we talk beneath the surface, we say that life could exist in oceans or sea, wherever there is some kind of fluid present. Like in the case of planet Earth itself, you have various kinds of life present in the sea, in the oceans, right? So similar oceans can also harbor life, and later on that life can really transform to start living on soil or on the land in addition to the sea, and then the growth starts. So currently the way we are looking for life is that it should be a life which gives you a signature of what we perceive today as life. But if you look at a seed which is lying, right, but it is not germinating, it's dead. But the moment you put the seed in the water and it takes water and it comes back to life and you see a plant growing. So there may be possibility that seeds are already there around in different planets in our solar system or planetary bodies like satellites in the solar system. And it is waiting for the right environment and opportunity for it to start thriving. So it's a very difficult question for telling how do I search for life. Only thing is we take clues from our own understanding and we say probably life could be like this or like that. And we have to see whether this life is something very similar to a single cell life or double cell life or a multiple cell life. And then we look for signatures in that to see whether it is very similar to what we know. But still life could be something which we are still not aware of. And similarly, when we talk about going outside our solar system, we talk about exoplanets and we say that life could exist on those planets which are in the habitable zone. Habitable zone means they are at sufficiently far away from their own sun and may harbor conditions which will be conducive for life to exist. And that's why we look for different kind of exoplanets. And it is, I believe at least, to me, I believe that it is very difficult to imagine that the planet Earth is so fortunate to have life on it and nowhere else. So I still believe life would be existing within our solar system in some form or other, and certainly beyond our solar system.
Thank you so much, sir, for that comprehensive answer. Searching for life, especially in outer space, is truly $1 million question. which is something which we as a human civilization have also not been able to clearly define till the present time. This also brings me to the next question which I have for you today, which is, while being a space scientist, one often has to work with large volumes of data as well as advanced tools like telescopes, satellites, etc. So what are some of those essential skills and tools which the budding space scientists might develop right now so as to excel and make a name for themselves in this prestigious field?
So essentially what we need is tools or basically analytical understanding. So the primary requirement is analytical thinking. It could be analytical in terms of mathematics, analytical in terms of physics, analytical in terms of chemistry. And the tools required basically are understanding of the process. As I was mentioning, there are now fields which are interdisciplinary in nature. So I can take biology and I can take physics and then add together I can become biophysicist. So that is the kind of analytical capabilities which is required for us currently, which actually comes when you understand the nuances that you are bounded or you are not able to progress because you are not aware about other fields. And that's why the scientists talk to each other and try to understand how do I understand. For example, I'm talking to you right now, right? Now, if you look at this process which is happening between two of us, is that I am talking, signals are getting converted into electrical signals, my video is being captured by camera, it is being converted into electrical signals and they are going together through a process which you call as communication, and then it is going into your computer or your laptop and it is getting decoded, and then you are able to see it and you are able to hear it, right? So this is one simple way in which we understand how much physics is going inside with so much electronics getting into the play, right, currently. And you imagine how many different ways in which you are receiving the signals through the communication means, which includes going through your Wi-Fi or something like that, and then going to the satellite, and then it is going again to your place in Lucknow and wherever you are sitting and things like that. So essentially what it means is that you have to break down this and say what are my areas of research interest. Whether I want to be a communication engineer, whether I want to be an engineer which makes new softwares through which I can communicate. So one is hardware part, other is the software, right? And they have to work together to make the process happen, like what we are talking to each other, right? So there are various ways in which one can contribute. There are ethical ways, there are software ways, there are hardware ways. And hardware also, you need material to develop that, right? For example, semiconductors or ICs, integrated circuits, where you have so many diodes, triodes sitting together and making a small chip which has a capability to do a lot of work at a given point of time. And therefore, this, what you call science and technology, has become a very complex in certain ways, but if you break down, you can choose your own area in which you want to contribute, and that depends upon what is your liking. So it boils down to your passion, and if you continue your passion with full vigor, full energy, you can really achieve it.
Absolutely. So thank you so much for that. And now that we understand the nuances of what goes behind, a vast field such as space science in terms of the science that is required and the mathematics that's required, I'd now like to ask you a question about a slightly different domain, and that is international collaborations and partnerships are very common in space science. So with scientists working from different countries, and working together on missions and research projects. So, how are these collaborative efforts navigated, and how do they contribute to the global space exploration endeavors? Could you please tell us more about that?
Okay, there are two aspects in this. One is science and the other one is technology. Okay. In certain domains of high-end technologies, people means I should say nations or space agencies, they don't share high-end technologies. For example, when we had to develop the landing technology, going to the moon and doing soft landing, it has to be developed within the country. So, or you have to have some kind of defense programs, right? For any kind of attack from any other country. Those kind of technologies has to be developed within the country. Nobody shares those kind of technologies. And that's why if you look at the space program of the country, it all started with Dr. Vikram Sarabhai, who started dreaming about having a rocketry program within the country and satellite program within the country, right? But when you talk about science and trying to understand what the data is telling about when we have made observations, yes, a lot of scientists collaborate with each other. And not only they collaborate, they discuss around, they share the knowledge. One way of doing it is, of course, doing publications where we share our knowledge of what I'm finding, and then others look at it and then say, oh, this could be signals of this kind, and that's why it could be this process. So sharing and collaboration is an integral part of science because that allows you to grow into domain of science. But when it comes to technology, there are certain technologies which are shareable, but there are certain technologies which are not. And therefore, those which are not shareable, you have to develop within the country or within the agency or within the institute.
Thank you so much, sir, for that comprehensive answer and for helping us understand how sharing and collaboration is divided into two parts, science and technology, and how technologies are sometimes shareable, sometimes not, and how science developed in India over that period of time, starting right from a dream or rocketry project to turning into a reality of Chandrayaan 3. Sir, this also brings me to my next question, which is also the last question. The last question which we have for you today is, what is that one piece of advice which you would like to give to the budding space scientists who are passionate to make a name for themselves in this prestigious field?
First thing is, continue your passion and continue your passion with the full strength and full vigor. Don't lose it. Second is, if you look at the government is allowing a lot of startups to start in the area of space sciences. Whether you want to develop a software, you want to use or do any application, you want to develop your own satellite or even the own rocket, right? So there are many ways in which you can contribute by continuing into carrying your career forward and doing what you like to. So what you like to do is depending upon you, right? And if you continue to that, you will find people around you who will also be like-minded, and you can join together and do a startup also nowadays. And government has opened up now this area of space science and space technology or space exploration in a big way through giving various opportunities to young scientists and young engineers like you people. And therefore, this is a good opportunity for all of you to look at a career in this domain. It is of course challenging, but if you continue with your own thinking that you are doing the right thing to do and you like to do, please continue to do that and you will achieve success.
Thank you, sir, for your motivating words. I'm sure everybody who's been a part of this particular recording and who has been watching this will I've gained a lot of insights about this amazing field. So thank you so much, sir, for giving off your time. And I'm really glad that we were able to chat this morning and learn so much about, making a career in the field of space science. Thank you so much, sir.
Thank you, Roman, and thank you, Keshav,
Thank you so much, sir.
and thanks to your college.